Alonso, researcher in Tecnalia, and I will give you an overview on the second system we have developed in three-heat pump project, the dual source system. So starting the background of what's this technology, hybrid systems are an innovative alternative to either aerothermal or geothermal heat pumps, meaning they can use both sources or sinks for the heat pump. And normally a geothermal heat pump is used where an additional heat source or rejection heat exchanger is added to the system. And so these systems are useful especially when buildings' heating and cooling demands are not well balanced. For example, in cooling dominated climates, they can avoid excessive heat rejection to the boreholes, and so the borehole length can be reduced, and so the investment cost is reduced as well. And in heating dominated climates, they can mitigate the ground temperature decrease, an excessive decrease, and so they can improve the ground source heat pump operation. Normally, the commercial systems use, as I said, geothermal heat pumps plus dedicated air-to-water heat exchanger, external heat exchanger. Some research has been done on dual-source heat pumps, and this research is mainly focused on parallel systems, so systems in which a parallel heat exchanger between the refrigerant and air and the refrigerant and water or brine is included. And normally what's claimed in the literature that it's difficult to control the amount of refrigerant distributed among both circuits, so these systems are kind of difficult to optimize and to operate. And in other sources of the literature, COP increases of up to 88% were claimed at system level. So this lead to high reduction in investment cost and operating costs. So what is three heat pumps approach for this dual source system? Well, the main innovation is the dual source heat pump. The dual source heat pump used for heating and cooling. So it is a reversible heat pump, and it's using geothermal and aerothermal energy as a source or a sink for the heat pump. And the main innovation is it's using a combined evaporator condenser with air, brine, or both at the same time in a unique device, in a unique heat exchanger, the so-called the dual source heat exchanger. The heat pump is using a natural refrigerant, propane, and it's integrated in the system, including photovoltaics and electrical storage for the heat pump and for household electricity demand. And the same way as the other system is governed by an advanced energy management system. Okay, this is an overview of the heat pump included in the building's thermal system. And so it can work in heating mode using air, the fan here, brine from the geothermal boreholes, or both at the same time in order to provide the space heating and domestic hot water. It's reversible, so it can work also in cooling mode, the same as in heating mode with air, brine, or both at the same time. And the system can also provide free cooling by exchanging heat directly with the boreholes. And the system is controlled for making a choice in using the air or brine, and also for the free cooling control. So research activities we have been developing with this dual source system. First of all, the definition of the system configuration and working modes. Then the design, construction, and testing of a dual source heat exchanger and heat pump. This is the, sorry. This is the dual source heat exchanger that will be explained later. And for the dual source heat pump, we have constructed a first prototype with bare tubes and a little more complex refrigerant circuit. It was the first one. We have tested it, and then we built also a second prototype which included enhanced tubes, and also the refrigerant circuit was optimized. So this allowed us to reduce the unit size and also an important refrigerant charge reduction. Also, system is simulated and tested. This is ongoing now. And finally, extrapolation of the simulations for several European climates will be done. Okay, so which are the advantages of this three heat pump system? First of all, for the use of the dual source, we can reach a reduction of the borehole length by an estimated 50% when compared to ground source heat pump with the same efficiency. And we believe it can lead to between 15–20% lower investment cost on the complete system. And also it's using natural refrigerants. As said, well, this is used more and more each day due to regulatory issues such as the F-gas regulation. So we have requirements now for low global warming potential fluids. And so the use of natural refrigerants is spreading in cases where it is technologically safe and economically feasible. And in this case, in the dual source system, propane is used as a refrigerant. Thanks.